All right, cool. So I wanted to show what it would look like if we were past the point of defining KPIs and auditing our clients' data sources and then ready to blueprint their systems. So I'll show a little bit about a typical data stack configuration that we would put in place for our clients. It can definitely change a little bit client to client, but this is a typical blueprint. So first things first, where do we get our data? So we talked a little bit about that in the last video, but typically we're getting our data either through a third-party connector. We tend to use Airbyte the most. It's open source, has a lot of great connectors, or an API. And then we'll typically, if we're doing some custom development, we use Python to extract the data. And so that's like our typical go-to tool set for extracting data. There's other things that might come into play. Sometimes we'll get data from an S3 bucket. Sometimes a client will need to access data via an SFTP or something of that nature. But this kind of encompasses most of the ways that we get our data for our clients today. And then sometimes we will use like a managed version of those tools. So for example, Airbyte offers like a cloud hosted version. Our API and Python self-developed connectors, sometimes we will use like a managed version of Orchestra or Dagster to run our code, but sometimes we're going to spin up our own virtual machine using Amazon EC2 to power the compute of those tools. So if we go fully open source, we'll probably spin up some sort of virtual server like Amazon EC2. Typically, when we extract our data, we're going to send it as an intermediary step to the cloud storage system. This is partially to alleviate long-term vendor lock. So typically what we'll do is we'll extract data in Parquet or CSV format and store it in a cloud storage system so that you have somewhere where the raw data is being stored on a perpetual basis, or at least for a relatively long term. We might only have a certain number of day retention policy on your cloud storage, but the short story is we'll put your data in a place that is decoupled from your data warehouse and your BI tools. And so that's the purpose of these tools, is that we'll intermediately store your data in a cloud storage service. From there, we will load your data into Snowflake. So a lot of times we're probably using like an AWS Lambda function to do that, or we could use Airbyte for that. We could use custom Python code for that, but we could even use automated like Snowpipe ingestion in Snowflake. So there's a lot of options. What we're doing is we're loading the data into raw storage, and then we're loading the raw data into Snowflake. Then we use one of our favorite tools, dbt, to build really well-crafted data models to be used in analysis. So for example, you might get data out of your ERP system like NetSuite or Sage that has all of the core information that you care about, but it's at a very granular level and something that might not be very easy for your team to actually analyze. And so what we'll do in dbt is build like really nice, easy to use data sets that might pre-aggregate some of the metrics that you care about, or at least make it so that the data sets are very easy to use, a lot more user-friendly, human-readable columns, that type of thing. And dbt basically allows us to run SQL queries on top of the raw data in Snowflake and then load data back into Snowflake. With those tables, it's a lot easier to use. And so once we've set up that process, we typically follow like the Kimball data dimension modeling techniques, where we have a bunch of dimension and fact tables, maybe some metric tables for specific pre-aggregated analysis, and then we're pretty much ready to push your data into the BI layer. And so once we've developed those really clean tables in dbt, so like your dimension, fact, metric tables that make it easy for analysis downstream, then we're pretty much ready to plug everything into a BI tool. So we're official partners with Omni and Metabase. We've really taken a liking to working with those tools recently. They have different strengths and weaknesses. Omni is going to be a little bit higher budget, but has a lot of functionality, including like kind of the semantic layer capabilities. And they have a lot of really great AI features as well. A higher price tag, but there is a lot of great functionality that comes with a tool like Omni. It's very similar to Looker, honestly, but a little bit lower price, and seems to have done a good job improving on some of the things that are left to be desired with a Looker. Metabase is lower price point, but super easy to get started. We typically will develop our tables for our clients a little bit differently depending on which tool of those we choose. And I've also listed some other BI tools that we have experience with below. Sigma, we actually don't have direct experience with, but I've heard a lot of great things. So could be interested in exploring that someday. But we've built things in Power BI when that's the client's preference. We used to use Looker a decent amount. Haven't in a while now, still a really great tool. One of the tools that I've purposely left off and might be controversial in some circles, but Tableau, we just don't find that it's the best tool for most of our clients. Tableau is great for people that are great Tableau developers, but it's not necessarily the best tool for somebody that is not a Tableau wizard, basically. I think a lot of the other tools are a little bit easier to pick up, at least from the front end perspective, than Tableau might be. And so that's typically some combination of what we're looking at on the screen is how we will go about implementing our data stacks for our clients. But then one of the most important things is that we use an orchestration tool to manage how all of these moving parts interact with one another. So we want to make sure that the data extraction works properly and that we're loading that into cloud storage before we trigger anything to load data from cloud storage into Snowflake. And then we want to make sure that load process works properly before we trigger any DBT jobs. Then we want to make sure that our DBT tables have all refreshed before we refresh anything that's in the BI tool. And so we encapsulate everything that's on this page with a tool like Orchestra or Dagster. And those tools basically allow us to do just that, which is make sure that everything's happening in the right order, observe any errors in the data pipeline, make it super easy to backfill or retry any failed data pipelines. We've been gravitating towards Orchestra lately because it is a lot easier to hand off to our clients, especially if they're not extremely technical in background. Has a friendly drag and drop user interface, whereas Dagster is fully driven by code. They have a structure in place that makes it very easy for people that are familiar with Python to set up data pipelines in Dagster, but Orchestra is going to be the most user-friendly just to get up and running with. We use Dagster in some cases, especially like if we want to build a fully open source data stack, but Orchestra is our preferred partner and I really loved working with them lately. And yeah, if you're interested in learning more about how we can implement something like this for your business, feel free to reach out and then check out our next video about our entire end-to-end data stack process called Clarity.